that is graphics and data visualizations with Matplotlib. Uh, at the very outset, I like to tell you that Matplotlib, there are different functionalities and features to represent graph. All these features is not possible for me to cover in this short period. But whatever I'm trying to represent as demo before you, probably that is more or less enough to represent your purpose, serve your purpose in a short way. And after that, even if you want to add more functions and features in your graphics and data, then one can do it. And there are so many websites, and Matplotlib own websites is there, dedicated websites is there. One can go and improve their function graphic output. So let us start with this way. I suppose want to plot a simple graph like y equal to sin x. So it's very, very simple to draw a graph in Python, but for which you have to call or import a library called Matplotlib, under which there is another functionality called pyplot. So I import numpy because I have to create every time some arrays. So basic purpose of call importing numpy is this. And this one, import matplotlib.pyplot as plt. This will serve my graphics purpose. So when I'm trying to plot a graph like y equal to sin x, Colin, can you hear me?
Yes.
So it's 11:39 in my laptop. So we'll go up to 12:10, I think. All right, I understand it. So I have defined an array for x, that is x equal to np.linspace 0 to 10, 50. So the idea is that when you are trying to plot a graph like y equal to sin x, that means for each individual value of x, you are evaluating y, and along x-axis you will plot x, and along y-axis you will plot y, and that is the features. So what you need at the very outset, you have to create a series of values for x, and for each values of x you have to calculate y. And how will you calculate? By using these sign functions. So first thing that you have to do, you have to create an array for x. That you can do by using linspace functions. That is, you create an array from 0 to 10, suppose, with 100 points in between 0 to 10. Then you calculate y. What is y? Y is sin x. So you write np.sin x and check it out whether it is evaluated or not. Oh, sorry. So you have got your, for each value of x, I can also show you x and y also. So this array, these are all your x values, and corresponding to each x values, you have calculated your sin x. These are the values. So x array, y array will be plotted against each value of x. So how will you do it? This is x array, this is y array. So you will do it like this. Put it in the bracket. You have got your result. So for drawing or plotting a result for independent variable, there will be an array for dependent variable that you are going to calculate with this independent variable array. This is be put like this. Then put the command plt.plot and you will get your output. But this output doesn't look very nice because you can understand what is going over here, but if somebody else, third person, if it looks like this, he will not understand anything over here. So I have to improve this one. So these improvements I will discuss one after another. First of all, suppose I want to increase the line width, then what I will do, I will put a command like line width equal to something. I have put here 5. So instead of 5, suppose if I put suppose 10, it will look like this, very thick. If you put suppose 2, so this is how we can change the thickness of your line. So this is one feature that you can put in your plot. Then suppose you don't want your solid line, you want to put something like dashed line or dotted line or dash dot like this. So if you want to change the line style, then there are some features available in Matplotlib. That is, solid lines you can write simply like solid, or put a symbol like this, one dash. Or if you want to get a dashed line, you can put dash or double uh, dash or dash dot simply like this. So these are the some of the features you can put. So here I have shown dashed. If you want to put like dash dot, then just change it to dash dot. So it will look like this. Or if you want to put it like simply dot, sorry, not dot, it is dotted. It will be like this. Or if you want to use a symbol like this is also very simple. This is the solid line. This is dashed line. This is dash dot. Or if you want to only dot, put simply dot. It will like this. So next, I can change the color of my line also. So these are standard colors: blue, B for blue, G for green, R for red, C for cyan, M for magenta, Y for yellow, K for black, W for white. So you can always try it out with different colors. Suppose I want to put it, suppose cyan. This will be the color. If you want to change it to magenta, then you can put M. It will look like this. So you can change the color of your line also. Now suppose you want that you don't want any line, only markers. I mean the points, the whether it is experimental points or evaluated points, whatever you say. So in place of line style, you just put none and keep marker on, then you will get a feature like this. Or if you don't want marker, you put it none over here, and instead of the line style, you just write solid line. Sorry. Okay. Now we can change the size of the marker also. So if you make it suppose 5, it will be little less. If you want little more, put it suppose 8, a little low. So this is how you can vary as you want. Then most important part is that legend. What this data represents? It may be temperature, it may be suppose velocity, or it may be any physical parameters. So without a lesion, your data is never complete. So lesions are soul of this graphics. So how to put lesions in your figures? So everything is going along like this: independent variable array, dependent variable array, line width, line style, colors, marker size, everything is okay. But if you want to put lesion, just write level equal to what lesion you want to display. Here suppose I have put test data. If it represents temperature, then you can put temperature. If it represents velocity, you can put velocity and whatever it is. So this is how you have to put lesions, that is you have to write level. And one more command line, that is plt.legend within bracket, then it will give you this result. Now this most important part is, another part is that figure size. Figure size is that what will be the width and height of the figures. So this you can do by writing plt.figure within bracket figure size, width and height. Something I have done, I want to change it suppose 4 by 3. Very small. This is not appreciable. You can make it suppose 8 by 5. Better. So according to your need, you can define your figure size. This is another important aspect in graphics, simple graphics. And last but not least, the most important part is that when you are going to publish your figures, some journals, or even if you are making a note, you want to put it in your documents, then if you don't save this figure, that is, it is an useless kind of things. So you have to save it figure by writing plt.save figure within bracket, just give the name of the figure. I have given the name fig name dot, either you can give the extension png or jpg, whatever you like. So this figure I have saved it like test figure.png. So the working folder or directory or working folder where I'm working here, or my notebook is open, this figure will be stored there. Next, another feature is that how to set. Yes.
So can we change the position of the legends, because in some plot it comes in the lower part, in above.
That is very that can be done in the plt.legend. You have to write, I think top right. I may be a little wrong also.
Okay. So, yeah.
Top right. Listen, top right or top left. Some options are there. If you go to the Matplotlib documentation, you can find it there.
Yeah. Right. Okay.
So then bottom left. This is bottom. This is how this can be done. Okay. Wouldn't you have to give your options here? Okay.
Yeah.
You can check it out. Because very difficult to remember so many options.
Yeah, I understand. Okay.
Okay. So next is that setting some axis properties. That is axis properties means.
Hello.
Hello. Please
can
carry on.
Yeah, I am Tamal Sarkar. Can we save it in format?
Which format?
PS PostScript.
I don't know actually. I have never tried, but maybe is the PostScript extension is EPS?
Yes, sir.
Or
EPS.
PS? EPS probably it is. Or is it PS or PS or EPS? You can try it out. If you are working in the Linux environment, and if you are working like this way, you can try it out. Give the extension PS and go and check in your current folders where you are working. Probably it will be stored there. This is possible. I have not tested. I work in the Windows environment and I work with PNG or JPG extensions. That is foolproof, but I have not tested with this one, PS kind of things. Okay.
And one thing, the leveling of the axis is it also possible? I think so.
Pardon?
Leveling of the axis.
Yes, yes,
axis
I'm
leveling,
coming.
like
I'm coming. I'm coming to this point also. I'm going a little slow. Now I can set some axis properties. Axis properties means limit and scale. That is, suppose I want to limit the scales from 0 to 10 is there. Probably suppose up to 10 it is not necessary. I want to restrict it up to 5. So I can limit the scale from 0 to 5. Or I can set some levels because this picture is not complete. I don't know what actually x-axis represents and y-axis represents. So I have to put it like this way also. Our tick marks. Here it is automatically, it has been, it has calculated and put 0, 2, 4, 6 like this. But I may think that this is not good. I want to put it like 0, 1, 2, 3, 4 like this. So this sort of
Hello,
things, yes.
sir. I'm Yogesh. I just want to know that why this test command is required. Test data,
Which command?
test data above one. A label equal test data. What is required?
Okay. I explain it. Suppose this data represents suppose temperature.
Okay.
If it is temperature, why it is not coming this way? Can you see it? Temperature is coming. Suppose if it represents,
Yeah.
if it is suppose represents velocity. So whatever it is, what data it represents, you want to send this message. This graphics represents these things, temperature, velocity, or whatever it is. That should come here as a legend. So that you will write in level within bracket.
Okay, fine, sir. Understand.
Okay, fine.
Fine.
So here I'm discussing about these features. That is, you have to manipulate your axis properties. That is, you can change the limits or scales. You can set some levels because without levels, it is useless. Nobody will understand what is going over there in the graphics. You can put some titles. What exactly this figure represents, whether it is velocity, distance, or whatever it is. Then setting tick marks. Whatever it is there, that is maybe not serve very good purpose. You want some more tick marks to incorporate. So how will you accomplish these things? This is very simple. Just put the command plt.xlimit. Xlimit means what is the zero minimum and maximum. So xlimit within bracket, put the range like this, lower range, upper range. So not range, lower limit and upper limit. And for y axis also you can write it like this, lower limit and upper limit. And you see final output is coming like this way. I have restricted from 0 to 5. So it will up to 5 values are not there. So it is coming to the closest one. And 0 to 1, see this is the range. Then label. What does x-axis and y-axis represents? Suppose x-axis represents x and y-axis represents sin x. So I want to put x over here and sin x over here. So what I am writing, plt.xlevel within bracket x and plt.ylevel within bracket sin x. Now somebody may ask me what exactly this one. Actually, this is the LaTeX format I applied over here because Matplotlib access LaTeX kind of writing. Sin x, writing sin x is very simple. But if it is something like this, suppose e to the power minus x square, then in simple way you never can write it. So in that case, you have to write it like in the LaTeX format. There is no other options. You have to write it like e to the power minus x square. Oh, sorry. No. Exp, sorry.
Backslash is not required. Backslash might not be required. Only E.
No, it is. Yes. Sometimes what happens, what you are saying that is true. In LaTeX writing, we are writing one slash. But in Matplotlib, when you are writing in the markdown concept, this is a markdown way of except matjacks and so many kind of feature formalities are there in Jupyter Notebook. Sometimes you have to put double slash. Then it will implement. So say it is coming like this way. instead of exp you can put it this way also. So this is how some of the formalities are like this. So some complicated mathematical expressions you can put it like this. This is a beautiful features in Matplotlib. So for X level you have to write like this, for Y level whatever it is there you have to write it like this. Now what does it represent? If I don't write it, you can verify it. This is very short, extremely small font size. If you want to improve the font size, then what you have to write? You have to write font size equal to 14. Here also give the same thing. So it's quite reasonable. It's better. Or you can, yes.
Without
yes,
rotation 90 degree, with rotation, without rotation, even it has taken the rotation thing, right?
Yes, by default.
Level?
Why I have written this one? I'm coming to this. I'm coming to your point. Next, I will explain this one. So font size 14. If you make it 16, suppose it will be little more obviously. So you can always check it out which particular font size is suiting you for your publications or for your documentations. That is up to you. Now coming back to his question, like rotations. Why I have written? When I'm doing my work, I don't put these features. I don't write rotations because by default it is coming this one. So I do not have to put this features already this one. But sometimes it is necessary that if you want to put it like this, it will come like this. Sorry. Yeah. This is for demonstrations only. I have brought this concept that according to your need, you can rotate your label by 0 degree or 90 degree or 180 or 270 just for exhibition purpose or demonstration purpose. But by default, it is coming parallel to y-axis, which actually we want always. Otri, are you getting my point?
Yeah, sure. I'm getting. It's by default it is 90 degree.
Yes. Just for demonstrations, I am just brought this one. Okay. Yeah. Next, tick marks. Suppose I have told you by default it is taking 0 to 46 like this. I want something different. So what I will write plt.xticks, and how repeatedly you want. Suppose from 0 to 11 with a step size of 2.5, or y tick mark should be np.arrange -1 to 1 with a step size of 0.5, and accordingly it is giving like this way. If you want something different, suppose not 0.5 2, and here it is suppose 0.25. It will look little clumsy also, no problem, but for exhibition purpose it is all right, demonstration purpose. So this is how you can vary your tick marks also. This command is very simple. plt.xticks, within bracket you put the range what you want, or you can manually also write. Even I've used the functions, arrange functions, but manually if you put within square bracket like this, suppose 0, 3, 6, 9, it will come like this way. So it is up to you. So you can manipulate your axis this way. You can manipulate your labels. You can put labels like this way. You can restrict the range also like this way. So these are some of the properties, axis properties you can do in your graphics. Now, this is one graph I have shown in one window, but sometimes if it so happens that you want to put more than one graph for comparison purpose in the same window, how will you do it? This is not also very difficult. Suppose I have a function called yx equal to x cube plus 5x squared plus 10, and I ask to plot these functions for different x values, and along with this one, the first derivative and the second derivative. Of course, I want a graphics output like this one. So how I have done it? The idea is very simple. I have to select a range for x, which I have done. My range has been given from -5 to 2. So I have created values between -5 to 200 values I have created with the linspace command. Now fx, it stands for the original function fx, which of course here it is written yx. So it is x cube plus 5x square plus 10. f1x is the first derivative, f2x is the second derivative. So when I write x comma fx, it is plotting a variation of x against fx. When I am plotting x comma f1x, it is plotting x variation of first derivative. And when I am writing x comma f2x, it is giving the plotting of variation of x of the second derivative. Color,
I have to define the derivatives.
I'm coming to this point also. I'm coming, just wait. Now I have changed the color codes just to distinguish. First one red, blue, green. I have put the labels also. The first one is the original function fx. Second one is the first derivative, so it is the LaTeX way I have put it. It is the second derivatives. I have defined a line width also. Yes, who is there?
Sir Tanuj.
Okay.
So I have a question regarding this color in the PLT plot. So you're using the color as red, blue, and green. You're inserting the holes and word red, green, blue, and green. In the previous, you're giving just color red for R for red, blue for B. Will that work in this context? Just color R or B just?
It will 100% it will work. Okay.
Okay.
So level is there, line width, line style, solid, dash, dash dot. This is different just to distinguish. And when you will run it, it will come out. Now coming back to Otri's response. This is simple way I have done it. Just to tell you this message that this Python is not doing only numerical calculations. It is equally competent to carry out analytical way of calculations. That is, this is the function defined over here, and through this command, I have calculated the first derivative of these functions. It is the second derivative I have done with this command. That is, this is,
sir.
Who is there?
Sir Tanuj, once again. So what does this imply?
Okay, I will explain. Just wait. Now, the first class I have told you, the Pythonic ecosystem, SymPy is also there, which is meant for symbolic calculations. Now, symbolic calculation means what? The very purpose of bringing this particular example is to tell you that Python can also do like mathematical like of calculations. Here you see. Sorry, I have not defined it. See, this is your functions, which it is given x cube plus 5x plus 10. Now I have calculated the first derivative. This is the command derivative, and before which I have to make, this is some of the style of doing calculation. I have to define that x is a symbol, and I have called this SymPy library everything. So f1 derivative fx, this will calculate the first derivative. Okay, I put it like this way. It will be helpful.
Hello.
Who is there?
Sir, I have one question. Yeah. Sir, in the graph,
I'm coming. Just wait.
Let me X on the top, just like
just
the bottom one.
Just a minute. Hold on. Let me explain this part. Then I'm taking your question. See, this is your functions. X cube plus 5x square plus 10. If you take the first derivative, then it will be 3x square plus 5x. Check it out. whether it is calculating or not. You have got it. Now, if you take the another derivative of this first derivative, this second derivative, then you will get 6x plus 10. I have done it, and I want to check it. 6x plus 10. So, for drawing this particular graph, I need not have to interfere. Everything will be done by coding. So, if I write this way, if I define x as a symbol, and if I define my functions which is given, and if I write these command lines, then it will calculate the first derivative and second derivative. So, through these simple examples, I want to tell you that Python, with its SymPy package, it is capable of doing analytical kind of calculations. Now, in the next sections, what I have done, x has been defined as a symbol, and all these functions f, f1, and f2, they are also carrying this analytical features. They are symbols. So they cannot serve my purpose of drawing graphs until and unless I change their character. That is, from symbolic character, I have to give a numerical characters. So that can be done by lambdify functions. So what I am doing, f equal lambdify x f within bracket numpy. That means x is also changing from symbolic character to a numerical character, and function f is also changing from analytical functions to the numerical functions. Similarly, for f1 and f2, I can do it like this way. So now, after this transformations, x, f, f1, and f2, all are having these numerical features. That is why in the next third sections, when I am writing x, creating a value between -5 to 200 points, and calculating fx, it has calculated all the values of fx. See, you can check it. I can show you. Oh, it has not been defined. Okay, sorry. So all values has been calculated, but for verification purpose, I am telling you, after doing this calculation, if you write f1x, f2x, or fx, you will not get any results, because till now it is having analytical character. That is, all are symbols at that time. But here I have transformed from symbol to the numerical characters. Okay, someone is putting some questions over there. Who is there?
Hello.
Please carry on.
Sir, yes, sir. I'm Yogesh. Sir, my question is that can we put tick mark on the top side and on the right side?
Yes, that is possible. That is also possible. That means you want this tick mark at the top. Here.
Okay.
In this part.
Use that command.
Yes,
yes.
In the top.
Where we can use that command,
this one, sir? At the
Where we can use that command for that?
There you go to the Matplotlib documentations. These features are there. You can pick up and you can implement that way.
Okay.
Logarithmic scaling? Logarithmic scaling?
Yes, possible. Very well, it is possible. Just you have to put that particular command lines, and you can take logarithmic scale also. You can draw your graph that way also. But I have not shown it here. So many features are there. Numerous
Everything is not possible.
Yes.
It's Devarka here. Hello.
Please carry on.
Is it possible to import data from some outer file?
Very well possible. I will show you the example. My example is there also. You can have a data file. You can call this data. You can import this data file in your Matplotlib. You can plot your data. I have an example. I will show you. Okay. So I have only 2 minutes 30 seconds. So I just want to finish this part. Then I will, in the next session, I will show all the examples. So this is a demonstration about the scatter plot, that is Cartesian and polar coordinates. This is a simple one. This features something like this. Now, how I am getting this one? This is a scatter plot in the Cartesian coordinates. This is a scatter plot in the polar coordinates. So what I have done, I have created an array of for x in np.random uniform from -10 to 10, and in between there 20 values are there. For y also I have created like this way. Then I have created theta and r. I know the transformation equations, how to calculate theta. Theta is y by x, and for all I in the range like this. This is the least comprehension, simple way I can calculate all the theta and r values. Then I have plotted scatter xy, and I have plotted scatter theta r. But when I'm doing it for the polar coordinates, I have to write an extra command like projection equal to polar, and that will give it these beautiful pictures. Now, why I am interested in showing these two graphs, here you can verify that depending upon the color codings, it is in the first quadrants, that is 0 to 90 degree. This light blues, they are also in between 0 to 90 degree. In between, that means if you consider concentrate on the Cartesian coordinate, you can see in between 0 to 90, first quadrant points are generally cyan and blue, and here also in between 0 to 90 they are cyan and blue. When going to the second quadrant, it is basically pink and magenta and red. Here also it is like this. And you can, in third quadrant, it is red and orange is there, red and orange. And in the fourth quadrant, all green and one cyan is there like this. So you can visually, just by inspection, you can say that your transformation is quite perfect. Perfect transformation has taken place. So this is the beauty of graphics and visualizations of data. Otherwise, and impression, and it gives a good